Hello everyone, we are doing exercises of chapter number 5 of H.C. Verma. This is question number 3. In a TV picture tube, electrons are ejected from the cathode with the negligible speed and reach a velocity of 5 into 10 to the power 6 meter per second in traveling 1 centimeter. Assuming straight line motion, find the constant force exerted on the electron. The mass of the electron is 9.1 into 10 to the power minus 31 kg. So here there is a cathode, okay. So there is a cathode like this, and from this cathode several electrons are ejected. So let me depict the electrons like this. So there are several electrons which are there near the cathode and they are ejected with a negligible speed. That means the initial speed u is equal to 0 meter per second, okay, or you can say about 0 meter per second, negligible speed, and they reach a velocity of 5 into 10 to the power 6 meter per second. So I am assuming here that the right direction is the positive direction and left direction is the negative direction. That is, all the velocities and accelerations towards right will be positive and all the velocities, acceleration or displacements towards left will be negative. So my u is equal to 0 meter per second and final velocity is 5 into 10 to the power 6 meter per second. This is towards right and hence it is positive. Now the distance traveled is 1 centimeter. So the distance is s. So since it is a straight line motion, I am writing it is plus 10 to the power minus 2 meter and considering it as a displacement because it is a straight line motion. Now we have to find the constant force exerted on the electron. Now let's find out first what is the acceleration of the electron. From this given information, how will you find out the acceleration? It is simple. We will use v square is equal to u square plus 2as. Now your initial velocity is 0. So I will just write 2as is equal to v square. Now a is equal to v square by 2s. So this is our acceleration. But now we want to know what is force. So force is equal to mass times acceleration. Okay, so in this case we have to put the mass of electron and it is given that the mass of electron is 9.1 into 10 to the power minus 31 kg. So now let's find the acceleration first. What is acceleration? V square. So now v is given to be 5 into 10 to the power 6 meter per second. So here I am writing 5 into 10 to the power meter per second whole square divided by 2 times displacement. What is the displacement here? 10 to the power minus 2 meter. Here it is 10 to the power minus 2 meter. So this becomes 25. 5 square is 25 into 10 to the power 12 meter square divided by second square. Here 1 by meter will be there, this one. So divided by 2 into 10 to the power minus 2. So what you get here? You get 25 by 2 which is 12.5 into 10 to the power 14 meter per second square. This meter square and this meter will get cancelled. Now we have to find out the force. So force is equal to mass times acceleration. Mass is given to be 9.1 into 10 to the power minus 31 kg into acceleration is how much? Acceleration is 12.5 into 10 to the power 14 meter per second square. Now here what we will do? We will multiply 9.1 by 12.5 into 10 to the power minus 31 plus 14 kg meter per second square. Note that the powers of these 10 will add. So this is minus 31 plus 14. So what is it? This will be minus 17 and 9.1 into 12.5 is 113.75. So this is Newton, the unit of force. So this will be equal to 1.1. I am shifting this decimal 2 places. So here I will get 10 to the power plus 2. 10 to the power plus 2 into 10 to the power minus 17 Newton. So the answer I will get is 1.1 into, add this power, minus 17 plus 2 is minus 15. So this is minus 15 Newton. So the force acting is 10 to the power minus 15 Newton. About 10 to the power minus 15 Newton. Okay. So this is the answer.